Sampling. Like Title 24, the NSHP program allows the HERS rater to sample. Let's take a look at the guidelines for solar sample groups. The NSHP program only allows the use of open group sampling. Closed group sampling is not allowed. All systems in a sample group must be from the same subdivision, by the same home builder or developer, and the same contractor or installer must have completed all solar systems in the sample group. Systems using different solar plans or layouts may be placed within the same sample group. Model testing of different solar plans or layouts will not be required prior to completing your sampling. No more than 15 systems may be assigned to a single group. However, a group may contain fewer should the group be closed prior to the assignment of the 15 systems. A sample group will be considered open once a system has been assigned to the group. A group will be automatically closed once the maximum number of sites has been added or 6 months has elapsed from the date the group was opened. You will follow the same procedure for dealing with failures that is utilized for Title 24 HERS verifications. For example, in your sample group, the first verification that fails, you will be required to test a second sample within the group. If that second sample passes, you must then retest the first failure until it passes. Once both are passing, then the group will be deemed as passing and you can have your sample documents. If the second test fails, then you will need to test and verify every single site or system within that sample group. Solar equipment verification. The HERS rater will need to verify two things in relation to the PV equipment. One, the equipment type, and two, the equipment installation. Equipment type verification. You will need to verify the specific equipment used in the expected performance calculations, as documented on the FI1, is actually installed in the field. This equipment will consist of the PV modules, the inverter, and the system performance meters. Now, the system performance meter will only need to be verified if it is not an approved meter that was built into the inverter, so it would be a separate meter. Commonly, what you will find is that the inverter has an integrated performance meter, therefore that performance meter does not need to be verified because it is part of the inverter. The NSHP FI2 should list the meter model number if the meter is not built into the inverter. Equipment verification of PV modules. You will need to make sure the same number of each make and model of PV modules used in the expected performance calculations are installed in the field. Now you will be able to count the number of modules easily, as you can see the separation between the different panels. However, to verify the make and model, you will need to get documentation from the installing contractor. Now the contractor will install the name and type of PV module, and then they will need to provide you with documentation in the form of an invoice that contains the make and model numbers of the PV modules that were installed on that particular dwelling. As a HERS rater, you will verify that the make, model, and count of those modules are consistent with the FI1. Here's an example of some building integrated PVs. You'll notice that they lay in the same rows as the roof tiles. Each of these is about 4 feet long, and you'll need to carefully count each of these modules. Here's a little bit closer example of building integrated panels. Again, you can see that they are fairly easy to count from the right distance. If it is a rectangle or square, you can easily just count the number across and the number high and then multiply to get the totals. However, that's not always the case. Sometimes they are laid out in different patterns where that process won't work. Again, just another close-up However, this one does make it a little bit more difficult if you are viewing from this angle to count each of these rows of panels. So sometimes there will be some challenges you'll encounter. Here are some rack-mounted PV panels. These are much easier to count. They are easily defined by the silver in between each of the panels, and they are not mounted directly in with the tile. They are mounted on top of the roof structure itself. And in this example here, you'll notice that there are some shading issues there to the system on the left, which we'll talk about those requirements later. In this example, you'll notice that there are two different types of solar arrays. There are photovoltaics on the right, and then what appear to be solar water heating on the left. Be sure that you can distinguish between the two different types of arrays. And here's a closer view of that same rack-mounted system. From this view, you can more easily see the rack system that those are mounted on. You can see that there is a gap in between the back side of those panels and the roof deck itself. And this distance will affect the performance of the panels. It'll allow them to run a little bit cooler, having that airflow below. Now you don't need to verify this height, just the number of panels that are installed on that roof. Equipment verification of the inverter. Make sure the inverter is the same make and model specified on the FI1 and that it is listed on the SB1 incentive eligible inverter list on the Go Solar website. The PV installer will install the same inverter used in the expected performance calculations, and the HERS rater must verify the make and model of the inverter. Every inverter will have a location where you will find the make and model number. For this example here, in the lower left-hand corner, you will see a label that lists the make and model number as well as a lot of other information. These two examples, again, there is a label that's clearly located on the inverter that will give the make and model number for your verification process. This is just another example of a different type of inverter, but again, make and model will be clearly labeled. And this is yet another one. You'll notice that many of these inverters are mounted indoors and some are mounted outdoors. Again, you will find various types of locations for the installation of these inverters. Equipment verification of the system performance meters. Make sure either a separate system performance meter or an inverter with an integral system performance meter is installed. If the meter is not built into the inverter, it must be listed on the incentive eligible meters list on the Go Solar website. The HERS rater must verify the make and model of the system performance meter matches one from the list. The make and model of the meter will not be indicated on the NSHP FI1, but will be indicated on the FI2. This is a separate system performance meter, one that is not integrated into the inverter. These are not as common as the other type, but you may encounter them at some point during your inspections. Again, right on the face, you will notice that there is the make and a model number of the equipment for your verification purposes. This is just a second example, but again, you can see clearly labeled on the front of the inverter is the make and model number for your verification. Equipment installation verification. The expected performance estimates are based on predetermined installation parameters such as azimuth, tilt, and mounting height. However, we will only be verifying the azimuth of the array. The rater must verify that the azimuth of the PV modules installed in the field are within 90 and 280 degrees of true north, within plus or minus 5 degrees. Now, some arrays may be installed outside of this allowed range. These arrays are most likely there to comply with Title 24 PV credit requirements and not for NSHP verification. You will only verify arrays that are documented on the NSHP FI1. In some systems, PV modules may be installed in multiple arrays with different azimuths. In these cases, the azimuth of each array must be verified. Azimuth is measured in degrees of angle clockwise from true north. As we see in the diagram below, north is represented as 0 degrees. As we move clockwise, east represents 90 degrees, south is 180 degrees, and west 270 degrees. In this picture here, we have two homes, each with their own separate PV array. Now we can see that they're facing in different directions, and it appears that the home in the background towards the left has an azimuth in a southerly direction, where the house in the forefront, its solar PV array, appears to be facing in a westerly direction. There are two ways in which you can measure the azimuth of the array. The first is to use the building plans. The second would be to use a compass. To use the building plans, you will need to have a plot plan that shows the bearing of the property lines. Azimuth of the roof surfaces where the PV modules are mounted may be determined from the position of the house on the lot relative to the bearings of the property lines. Your second option is to use a compass on site. Compass measurements must be corrected for magnetic declination. You'll then determine the array azimuth angle between compass north and the direction that the PV modules face. You'll need to stay 15 to 20 feet away from any objects containing iron or steel, as these will affect the accuracy of your compass readings. Magnetic declination is the angle between the local magnetic field and true north. The declination is positive when the magnetic north is east of true north. All of the points in California are east declination. You'll need to go to the NOAA website at the address below to determine actual declination for the zip code where the PV panels are installed. This diagram shows the differences between true north and magnetic north. You can see the lines represent the changes in the magnetic field as you move away from the black center line there. And you can see that most of California falls within about 12 to 15 degrees off from true north. So you need to make sure that you make adjustments to your compass to account for these differences between that magnetic north and true north.